Hello, this is ACM ICPC Training. I guess it's 32. Uh, well, today we are going to deal with the new problem from USACO. Is one of the recent aided questions. It's called wormholes. Apparently, wormhole is is about. Let me switch to the question first. Wormholes. All right. Well, apparently wormhole is from high energy physics experiments. Well, it's always there would be a theory that even though we cannot exceed the speed of light, so we cannot travel to the back. So physicists try to have this kind of thing so we can get a short pass through space. So in that way, we actually exceed the speed of light. Anyway, it's a simplified version of the problem. It means you have a lot of wormhole on your 2D map, and there is a cow. The cow is to be the simplified. The cow is only going to because it's 2D map, so we assume there is x axis and y axis. A cow is going to move only following the plus x plus, that's the x plus x direction. That means it's only going to moving right, heading to the right. Okay, and if because wormhole, you have an interpoint, you have a exist. They both can serve as a interpoint and exist. So, for example, like this, if A and B form a pair of a wormhole, so if a cow is here and heading to B, and once he is falling into this wormhole, he will immediately appear at A, and then he will go right again and go into B, and appear in A, and so on and so forth. So I should say she. The cow's name is Bessie. Yes. She will be trapped there forever. Farmer John form those wormholes, wants to know how many for a given number of wormholes, but no limited to the pair method. That means if you have 4 points, you can either choose A and B form a pair, or A and C form a pair, or A and D form a pair. In how many ways the Bessie will forever trap in between the wormholes? Well, this is almost the background of the of this question. Let's see the sample input. The sample input is 0, 0, 1, 0, 1, 1, 0, 1. The first value is x axis. The second one is the y axis. So apparently, it looks like this: 1, 2, 3, and 4. This is 1, this is 2, 3, and 4. So we can know the first solution. The first solution is 1, 2 form a pair, 3 and 4 form a pair. So we can have so the Bessie will trap either between 1 and 2 or 3 and 4, and that is the first solution. All right. By reading the question, you might said maybe, okay, 1 and 2 is one solution, and 3 and 4 is the solution. No, in this question, you form a combination for all those wormholes, and then if you find in such arrangement your cow, the Bessie, can trap them in some pair in between some wormholes, that considered as one solution. Another solution is 1, 3 form a pair and 2, 4 form a pair, so that the Betsy can start from here. He will go to 3 and appear at 1, and he will go and go to 2, appear at 4, and he will start again into 3, appear at 1, and go to 2, and then 4. This is one solution. You can also imagine more complex solution, like if I have 6 points. So I enter this point, I appear at 1, I go in at 2, I appear here, and I go at 4, and so on and so forth. This is also a solution. But in this question, 1, 2, 3, 4 is a solution. 1, 3, 2, 4 is also a solution. So we're going to write a program to find out how many solutions are there. So basically, the idea is, because the wormhole is formed based on the pair, so actually we are looking for how many arrangement of these pairs. Let's, I think, just take a look on the code. The code will be better to explain the things. Let's see. Yes, here's a code. I have an A, because our largest case is 12, so I get 13. So I can start from 1. So I can start the point A1, A2, A3, A4, A5. I start from 1 instead of 0, and my is a 2-dimensional, so I get a 2. So 0 means x exists, 1 is y exists. The B is to find a pair. The BI, if BI equals J, that means IJ form a pair. All right, it's as simple as that. C is a little bit complex to say. Is trying to say, because our cow is moving solely on the right, so Cij means J is right on J is the closest point at the right of I. So if the Betsy is going from going from I towards J, the first point he will if the cow moving from I to the right, and the first point he will face is J. So Cij, that means J is the closest point, is right on the right of I. I will see the code later. We'll need a little bit initialization. C and N, we have N points, and here is also a simple one. AI0 is the X value, AI1 is the Y value. Okay, here is a little bit preparation for C, for the array C. From I to N, if AG0 larger than AI0, that means J is basically on the right, is at right of I, and if AI1 equals to AJ1, that means J is not only at the right of I, but is right at the right of I. It's just in the right of I. And in this case, if is equal to 0, that means he's not he's not been assigned to a point, or if their difference in X is less than the previous assignment. Maybe let's say if I have a I, if I J, if I have a K, if before you find J, you assign to K. If K is the nearest. However, you find J, so just replace it, right? And then every trick is defined in this DFS. This DFS will return an integer value, and finally it's going to print that output, and that is almost it. Take look at DFS. But this function is targeting to generate all the solutions. All solutions means we need to find all the combination of the pairs. So as I said, Bij means I pair to j. So firstly, we need to find our who is the next, who is the next haven't been paired up. So from I to from 1 to n, if Bi equals 0, then break. And in this case, I is recording the first value we haven't been paired. And if I larger than n, that means everybody is paired. So I check. This check is to check if there's a cycle. If there's a cycle, I just return 1, else I return 0. It's pretty normal. The important part is this one. This one to form all the combinations. Of course, in order to record all the solutions, I need a variable sum. Sum is going to trace all the histories. For I plus 1, obviously, because we are in the increasing order, everything before is already paired, everything after is not already paired. So we start searching from I plus 1 to n, j plus plus. If Bj equals to 0, if Bj, j is also not pairing to anyone. So we assign I pair to j and j pair to I. Okay, this in the what they call in the two-way, not only one way, it's two-way. And based on this arrangement, we run DFS. Based on this pairing, we run DFS. That will generate that will decrease your solution's size to the solution haven't been prepared. No, to the wormholes haven't been paired, and then you sum this solution up. And finally, after you run this DFS, of course, you need to recover them, so they can run for other pairs. So Bi equals 0, Bj equals 0. All right. And now check. Check is to check if I have a complete pair. That means I have already paired up all the wormholes I have ever found. Then I am checking if there is a way to trap my cow. From I to n, it's pretty simple. We start from I. Our cow is start from I to work from I, and then you will find that, let's see, if your cow is not trapping, so he will actually travel all of the points without a doubt, and he will go through it smoothly and finally go to the infinity of the positive direction of x. However, if it's not, in n steps, he's going to his repeating is already began. He will revisit exactly the starting point at the revisits the starting point in n steps. Yeah, that is more makes sense. As I say, Cij, J is the closest wormhole besides I. So if I start from temp, I want to know the one of my right. No, the closest point of my pair. Because finally, if I go into I, I'm going to out from my pair, and I want to know who is on my right, and that one is my new starting point. So at the end, because we're not using the first one, the first value is always from 13, so we can use 1 to 12 to record down our tracks, but we're not using C0, B0, A0. So finally, if is not equal to 0, that means it's still inside these wormholes. That means you already have a cycle, so you return true. And otherwise, if you find a 0 or you find out the ends internation, you have nothing, you just return false. And this is almost idea of this question. It's a complete search, but it's more like a recursive version of complete search. You need to search all the states. I guess that is almost it. Thanks. Thanks.